Okay, here's warm-up 10.6. All right, the letters of the alphabet are placed in a bag. So we got to know that we've got 26 letters in the alphabet. That's going to be key here. All right, find the probability of randomly selecting a vowel or the letters of quiz. Q, U, I, or Z, okay? So we have some letters that are in both categories here. We have letters that are vowels and also are in this word, the U and the I, right? So that means I want to find the probability of pulling a vowel, and I want to add that to the probability of getting a Q, a U, an I, or a Z. But I don't want to double count the U and the I because they're in both groups, because I've got these two favorable groups, right? But the U and the I are in both groups, so I usually just say both. This is I want to subtract out the probability that both of these things happen at once, so that would be the U or the I, okay? So a vowel, let's think about this, A, E, I, O, U. Let's not count Y for this problem. So there's 5 vowels, right? 5 vowels out of the 26 letters. These Q, U, I, and Z are 4 of the 26 letters. And then I've got 2 letters that are in both of those groups. Okay, so then add it all up. We get 9 minus 2 would be 7. So I've got 7 of the 26 letters are either going to be a vowel or in the word quiz. Okay. All right, next up, how many 7-digit phone numbers could be formed if the first digit cannot be 0 or 1 and no digit can be repeated? So these password problems, I like to just kind of set up blanks. So 1, 2, 3, 4, 5, 6, 7 to get the structure of my password. Okay. And then I'm just thinking how many options are there in each slot. So in the first slot, it can't be a 0 or 1, so that leaves 2, 3, 4, 5, 6, 7, 8, or 9. So there's 10 digits if you include the 0, and 2 of them are off limits on this first slot. So that means I've got 8 options in that first slot. Okay. Now it says no digit can be repeated. So I would have 0 through 9 as an option here, except I'll have used one of the letters. So instead of having all 10 digits, whatever my first digit was, that's off limits now. So I've only got 9 options. This could be a 0 or 1 here, but it can't be whatever digit I used in the first slot. Okay. And then as I go along, this next one, now I'll have used up 2 of the 10 digits, so I'm down to 8, and then I'd be down to 7 and 6 and 5 as I use up certain digits because there's no repeats allowed. Okay. And then I just need to multiply this up. So let's see. And that gives me 483,840. A lot of options there. Okay. All right. That's the fundamental counting principle I used. I multiplied the number of options in each slot together in each category. Okay. All right. Next up, we've got 3 nickels, 2 dimes, 5 quarters in a purse. Okay. 3 coins are selected in succession. So we're going to pick one out after another. Okay. So we want to find the probability of selecting a nickel, then a dime. I need a comma there. Then a quarter. All right. Okay. And when we're doing one event after another one, we're going to be multiplying. Okay, and with replacement, that means we're putting the coin back in and then making the next selection. Okay, so it's the purse has the same contents on every draw. So then I'm just thinking, okay, there are 3 nickels, so it's 3 out of the total amount. Let's see, the total is going to be 3 plus 2 plus 5, right? If I add up all the types of coins. And that gives me 10 total coins. So 3 out of the 10 are nickels, 2 out of the 10 are dimes, and 5 quarters out of the 10. And you could reduce some of these fractions now, or you could do that at the end. It doesn't really matter. I think I'll reduce now. and that's going to give me 3 over, let's see, 50 times 2 is 100. 3 out of 100. Okay. All right, let's try without replacement. So that means we're going to find the probability of drawing a nickel. But then when we pull out the dime, probability of pulling out a dime, assuming that a nickel has already been removed. Okay. And then when we're pulling out our quarter, we're going to assume that both a nickel and a dime have been removed. So since we're not replacing the quarters, it affects the second draw, because there will be different amount of coins in the purse if you are removing the coins and not replacing them. Okay, so for the nickels, there's 3 out of the 10 that are nickels, but then we got to assume that a nickel has been removed. So that means now there's only going to be 9 coins left. Okay, there's still going to be 2 dimes in there. And then on the third draw, we're looking for quarters. Well, if only a nickel and a dime have been removed, still all 5 of my quarters are in the bag. But I have 2 coins that have been removed, so that means there'd only be 8 total coins left. Okay, so then I multiply straight across. So let's see, 6 times 5 is 30. 10 times 9 times 8 is going to be 720. Let's go ahead and reduce that. That's going to be 1/24 if you reduce all the way. It would reduce to 3 over 72, and then you could still divide by 3. Okay, all right. Next up, 2 cards are selected from a standard deck of 52 cards. Find the probability that 2 black cards are selected in a row, and we'll go with replacement and without replacement again. So when we're replacing, the contents of the deck are the same every time. So I just multiply the probability of pulling a black times the times the probability of pulling another black card. So with replacement, half of the deck, 26 of the 52 cards, so you could type it in like that, or you could just say 1/2. These would both reduce to 1/2. So that means there's a 1/4 chance of pulling 2 black cards if you got a full deck to work with on each draw. Without replacement, though, that means we're pulling a black card, and then our second draw, we haven't replaced that first black card. So we got to assume that a black card has already been removed from the deck. Okay, so I'm just going to use 1/2 for the black cards. That would be 26 out of the 52. Okay, but now on the second draw, there's only 25 black cards left instead of 26, and there will only be 51 cards. And then I multiply straight across. I'm going to get 25 over 102, and that will be reduced. And so that's our solution. And that's the end of the warm-up, and I'll see you next time.